I want to show you real quick how to take repeating decimals and turn them into fractions. There are times when you come across repeating decimals and it would be real nice if we knew what that fraction was. There are some common ones, 1/3, 2/3, that we know what they are. Now I'm going to show you a real short version of this. The official way to do it involves a lot of algebra, and for our purposes right now, again, we're just doing the shortened version of it. So let's take something we do know, like 1/3. Now we know 1/3 is 0.3 repeating. Okay? Now here's how this works. In your repeating decimal, find what your pattern is. Find the number or numbers that is what is repeating over and over. So in this case, it's a 3 that repeats. 3, 3, 3, 3. All I need to do is take that repeating section and put that in my numerator. So the top part is the repeating pattern itself. The trick, or the shortened version of all the algebra that goes with to prove how this works or to solve it, is you put a 9 underneath for every digit that this contains. So in this case, this contains one digit, so I put 1, 9. So I'm going to put a 9 in for each digit that I have. Now, when you look at this, say, well, wait a minute, this isn't 1/3. Yeah, but it can be. This is 3/9. Now, the last step of this is to make sure that it's in lowest terms. All you got to do is take your calculator, 3 fraction 9, hit equals, automatically simplifies or reduces, and you get 1/3. So it does work. Now, I wanted to check this. Okay, I started with 0.3 repeating. How do I check? Take the fraction you got, 1 divided by 3, and guess what? My calculator says the same thing, 0.3 repeating. So let's try this out on some others. Okay, so I can do 0.8 repeating. Take the repeating pattern, goes in the numerator. So this is just an 8 that repeats. Put a 9 in the denominator for every digit in my repeating pattern. I have one number, so this is 8/9. Okay, so that's my answer, 8/9. How can I check? 8 divided by 9 gives me 0.8888 repeating. Done. What if I have something bigger like 0.72 repeating? Take my repeating pattern, which is the 7/2, that goes in the numerator, 7/2. A 9 in the denominator for every digit of my repeating pattern. I have 2 digits, so that goes over at 99. So the fraction 72/99 is the same as 0.72 repeating. How do I check? Well, first of all, I have to reduce if I can. So I type in 72 fraction 99, hit equals. It does, it reduces to 8/11ths. So this is my real fraction. How do I prove that 8/11ths is 0.72 repeating? Real simple. 8 divided by 11 equals 0.72727272. So yeah, it works. Let me show you 2 more quick ones. Uh, 0.413 repeating. Take my thing that repeats. Actually, let's do this. What if it was written this way? 0.413413 ... Okay, so you have to look at this and say, what is the repeating pattern? Hopefully you say, oh, it's 413. So 413 is my numerator. I need a 9 in the denominator to match digits up top. So this is over 999. Is this in lowest terms? 413 fraction 999 equals the same thing, 413/999. So yeah, this is it. I am done. Check. 413 divided by 999 equals 413, 413, 413, 413. Works. Last one. 0.024 repeating. Okay, here we go. take my repeating pattern, 0, 2, 4, 0, 2, 4, 0, 2, 4, goes in the numerator, 0, 2, 4. Now watch what happens. Typically, you don't put the 0 in front of the 2, 4, so what we would do is erase that. This is 2, 4, but you have to be careful. I need a 9 in the denominator for every digit that is in the repeating pattern. This is not just 2, 4, 2, 4, 2, 4. It's 0, 2, 4, 0, 2, 4, 0, 2, 4. So how many 9s do I need? I need 3. 9, 9, 9. I mean, you could write it like this, 0, 2, 4 over 9, 9, 9, but it looks weird because we don't put zeros in front. So, is this reduced? 24 fraction 999. No, it's not reduced. I can reduce further, which is 8 333. That is your reduced fraction. Double check. 8 divided by 333 equals 0, 2, 4, 0, 2, 4, 0, 2, 4, 0, 2, 4. So again, this is the short way to take a repeating decimal, put it over 9s, and that's what your fraction is. An easy way to get an equal fraction. Now, I have to say one more part about this real quick. This process only works if the repeating pattern starts right away. Okay. So, well, what are you talking about, Mr. Vaughn? What do you mean? Here's when it doesn't work this way. 0.4, let's do this actually. 0.83333 repeated. So ask yourself, what's different here? What's different here is there was a stagnant number in front. This doesn't repeat. After that digit, then your repeating pattern kicks in. So this rule of 9s doesn't really apply to this. In a sense, it does later, but this won't work. This process won't work for something like this. So just keep that in mind. The repeating pattern has to start immediately after the decimal if you're going to drop in with this rule of adding 9s.